Hey, hi guys. So I recently watched the recording of the stream by Alexei. Well, he's Russian. Alexei more sounds like Ukrainian or Polish. So his name in Russian actually sounds Alexei Kutepov, and he's better known by his alias T Sodding Daily. And I watched the video titled "I made an Emacs plugin." And I felt like needing to say something about it because I was like watching it and I was like, I agree with this, I agree with this, I disagree with this stance, and like kind of it went like that. But this is not a reactionary video. I would never be able to make a reactionary video like the way how Preamble does it. He's like absolutely entertaining. I could never do this, and it just amazes me how these guys, how like some people able to actively write code, watch what's happening in the chat, and like talk about the process. I could just like, whenever I have to talk and code at the same time, I get like interview vibes. I just get sweaty. I start like, it just like, it's probably like, yeah, this is not a reactionary video, but I just wanted to say like, the title alone, I was like, well, we don't have plugins in Emacs. We don't call them plugins for specific non-abstract reasons, right? So imagine a plugin is something like, imagine on a philosophical level, a plugin is something you plug into, like if you plug into your outlet in your house, like a vacuum cleaner, right? Like you plug it in and you can start to play with the light. That's a plugin. But imagine, because the packages in Emacs, a package can change drastically the entire, like the way how your system operates, how your system of editing, like how your editor operates, how like, imagine if you had a device that you plug into your outlet and suddenly your house gets the ability to fly, right? Like it turns into, what was that anime, Howl's Moving Castle, right? And that's how the packages work. So that's why we don't call them plugins. But anyway, again, this is not a reactionary video to that stream, but I just want to talk about like package making. And today let's talk about words. Specifically, let's start with etymology, okay? So etymology basically matters because etymology matters because it shows you what a word actually means, all right? When you know the origin of the word, where the word comes from, it sticks with you better. You start using it more accurately, and plus you start seeing connections. So many English words have Greek, Latin roots, and that helps you to learn languages faster because all languages are connected, right? And honestly, it's just fascinating to realize that words change meaning over time. Like the word awful used to be a compliment. Ancient Greeks had a word, the idiotes, that just meant a person, regular person minding their own business, somebody not involved in politics. So why does this matter? Well, it shows what each society cared about, right? Greeks thought that the worst thing was not caring about your community. We today think that the worst thing is not being intelligent, all right? Over time, the same words changed meaning. So today, idiot means someone who's not smart, right? The words is like time capsules. And by following how they change, we kind of can discover what humans valued at different points in history. Language reflects how we think and what we value. And so understanding word origin is like a little bit diving into history and culture at the same time. And one of the greatest instruments that gives us etymology, it's Wiktionary. But Wiktionary also covers definitions, pronunciation, parts of speech, some translations, like it shows you related words, inflections of like specific words. Wiktionary is a comprehensive toolkit. I use it all the time, and that's why I decided to build an Emacs package to use it from Emacs. And let me show you how I use it, and maybe you will start using that too. So I actually wanted to structure this video in kind of in an atypical manner, in an atypical way. First, I'm going to show you the package I built. the features, how I use it, and that will be the consumer part. That part should be relatively short, and if at that point you decide to stop watching, just go install the package and start using it and never come back to watch the rest of the video, just go for it. I wouldn't ask to comment, to like or subscribe. It's entirely up to you. The second part would be a little bit longer. I will dive into the technical details. There will be an opportunity to learn some Emacs Lisp, and we'll together explore the intricacies of package building and publishing. I have not published this package yet. It's a relatively simple package, and maybe it will give you the foundation to build and publish packages on your own, and it will show you how easy it is to publish a package on MELPA, and maybe it will inspire you to start building things, because honestly, building things in Emacs is a good fun. So let's just get to it, all right? Okay, my name is Ag, and you're watching Emacs Propaganda. All right, let me open the package homepage. This is the homepage of the package. I call it wiktionary-bro. Bro stands for browser, so I suppose the right way to pronounce it would be wiktionary-bro or something. There's the description, the screenshot, usage. The main command is wiktionary-bro DWIM. DWIM stands for do what I mean. There's not much to it. It's a small package. It doesn't have to be big. Let me show the package in action. Let me switch to Emacs. Okay. Now in Emacs, if I just I have it installed, and if I just run it, now you see do what I mean means if there's nothing, if my cursor is not pointing at anything, it will ask for what you want to look up. But if I type something here, let's say Emacs, and I run the same command, it knows that I was trying to look up, oh, look at that. There is an entry for Emacs and Wiktionary, which is pretty cool. So there's a definition of the word, like some further reading. There's pronunciation, let's see.
Emacs.
Okay, this is UK.
Emacs.
Oh, like this is US, which is pretty similar, or I should say the same. And if you, some links, this is like visual, you can see it takes to Wiktionary page. And if I press enter, it takes to the Wiktionary entry of the page. And if it actually takes to a Wikipedia page, it's an external page, not a Wiktionary page. It opens by default in EDD, Emacs web browser, or Emacs textual browser. So yeah, you can, there's in a README I explain, like if you want this to open in an actual external browser, there's a way to do this, and it's pretty simple. So that's there you have it. That's the package. Oh, you can also change the language. Let's see. There's, oh, what is MG? I don't even know what language this is. So anyway, there are different languages. So let's see like some more complicated example for something in Spanish maybe, right? Like I open the package. Okay, this is showing me different things, right? And you can see that it renders things in org mode, and org mode is amazing. I always wanted it in org mode, and it took me a while to the initial version I wrote it last year. It took me a whole year of procrastination of making this right, because specifically I wanted to make it right for their conjugation tables, right? First of all, I wanted it to be in org mode for the reasons that org mode is very awesome. Org mode allows you have the outline structure, but outline structure that allows you to jump to any outline thing. Like my initial version was basically something like if I open this in Emacs web browser in EVB, it would look like this, right? So you can see that initially it opens, there's a lot of fluff there, like some banners, but I was getting the entry from the API, so it would be cleaner if I enable readable mode in Emacs web browser. If you in EVV, then it'll show in cleaner manner, but it's still, there's no outline. It's hard to find things. I mean, like, it's not hard, but it's like harder to navigate. It's not as nice as org mode. Org mode also has like features like sparse trees, right? Like sparse trees, like if I want to match something, right? If I want to match some pattern, it will close the structure. The entire collapses the tree, but it shows me the matches that the things that matching, so I can, you know, see things that match, and that is very nice. And there you have it. This is the yeah, we also have like language. We can change the languages, right? And there you have it. This is consumer part of the video. You can go ahead and use the package. And now I'm gonna dive into more technical. So let's go back to the structure, to the directory. We'll cut the package directory. I have some tests. Please write some tests for the Emacs packages you write. They're important. I mean, like, generally, please write tests for any software you're writing. We have that screenshot you saw on the page. We have changelog, which is not huge. It's pretty small because the package itself is small. We have makefile mainly to run the tests. I'll get to the details of this. The readme you already saw, and here's the single package file. Sometimes packages, more complex packages, can have more than one Emacs Lisp files. So let's talk about the repositories. When you want to publish the package, first, like you notice that this is a mandatory header. If you want to deploy, if you want to publish your package on one of the repositories, that you need to have this header. It's mandatory, or like at least some keys here are required, some are optional, but you do need to have this header. And there are multiple different ways to publish things, to publish Emacs packages, so multiple different archives. So there is MELPA, which is the largest repository, largest archive, and it's most comprehensive. It has like thousands of packages, over 4,000 or 5,000 packages, I believe. And this is it's if you start with MELPA, which is because it's the easiest choice. There's another one which is official. It's called GNU ELPA, Emacs Lisp Package Archive. This one is official, but the caveat here that it requires copyright assignment. So not corporate, copyright assignment. There's non-GNU ELPA. This one does not require copyright assignment. And there are some others. There's MELPA stable. It's for stable releases, but like in the beginning, I suggest start with MELPA for development, and once you ready to publish to ELPA and other places, you can do that. In any case, you will need this header, and if you typically you would just start like writing some code in a Scratch buffer, right? And let's talk about some Lisp basics. So around 1930s, Alonzo Church, a mathematician, he was contemplating what does it mean to compute something. And then so he created a formal language to answer that question formally, right? He created Lambda calculus as a language. And in basic terms, imagine you have to explain what is cooking, the concept of cooking to someone who never been in the kitchen, like, I don't know, like an alien, all right? And you can show them recipes, all right? But the recipes are too specific, and like each recipe like differs from one another, right? You can also show them around the kitchen. You can show them your knives and, but there's too much stuff in the kitchen. Or you can just describe the core idea. So you'd say, like, take the ingredients, mix them in sequence, apply some heat, and voila, you get a new thing, right? So Lambda calculus does this for computation. Instead of saying, what is a computer program? It's too vague. There are too many details. It just says a program is just a box. Like, it takes an input, transforms it with like some rules, and gives us an output. And these like boxes, these transformations can be nested, and you can reuse them. And every actual computer, every programming language, every algorithm, it all boils down to this core pattern. Church, interestingly, even proved that you don't even need like the simplest primitives like we take for granted, like numbers. He proved that to represent any number, for example, number 4, you just need to apply a transformation 4 times, right? So, those are called church numerals. 30 years later, John McCarthy, he was contemplating a way for a formal language to build AI systems. And he sketched a nice algebraic notation called M expressions. So M stands for meta, and he's a mathematician also, right? He envisioned something syntactically desirable, closer to traditional mathematical notation. If you actually look into like OCaml Haskell code, the syntax of M expressions, it's kind of similar. But while he was doing this, he kind of stumbled on this implementation detail that pretty much purely incidentally became a permanent thing. And that implementation detail is called S expressions, symbolic expressions. And a programmer in his team, I think his name was Steve Russell, he found that implementation detail, he found it so convenient to actually write code with this. And I remember reading some trivia about that when McCarthy strongly disagreed with him, and they had like heated debates about like, and he was like, you shouldn't be using this. This is like, this should be hidden. But he was like, he went on and he built something and he proved his point. All right. And another incidental detail that McCarthy initially wasn't considering Lambda calculus. He didn't say, I want to implement Lambda calculus. His path was like from I need some symbol manipulating language. It directly kind of led to Lambda calculus, because Lambda calculus is a fundamental structure of computation. It's like stumbling on the Newton's laws while trying to build a catapult. Imagine you're a medieval times engineer and you're trying to build a catapult, and you don't know nothing about physics theory, but physics theory is already there, either you want it or not, right? So these like incidents, they still with us together, and that's fascinating, because if you look at it, Lisp is like, what makes Lisp so uniquely valuable even today, after almost 70 years later? Why? And why would it still be valuable decades from now, and probably 100 years later if we don't destroy ourselves by then? So Lisp gives you purity. Lisp is Lambda calculus made visible. There's no syntactic noise hiding underlying structure. And if you want to understand computation at its bones, Lisp shows it nakedly. And that is pretty cool. There's also a philosophical clarity. Teaching someone Lambda calculus using Python is like teaching physics through a car manual. It's not impossible, but it's obscured, right? And if you really care about understanding what computation means, what computation is, and especially if you need like powerful metaprogramming, if you want to write programs that rewrite themselves, well, Lisp still remains unmatched. Okay? So, now, when I assume that you don't have any Lisp knowledge, and if you do, and if you get bored, like, please, like, fast forward. So my suggestion, if you're a very beginner to Lisp, you would want to start with structural editing. Don't skip this step. Structural editing commands are important because in Lisp you typically have a structure. Like, remember we talked about the structure of computation. That's what it is. You have like certain the pieces here, and every one of them, they kind of are like pieces of, like, they call it symbolic expressions, and every symbolic expression you can grab any of them because of the parentheses. Think of parentheses some kind of handles. You can grab them and move them around. You can transpose them. You can like get one into another, and so on and so forth. And this all possible because of structural editing commands. And if you want to use Emacs, there are there are multiple popular choices. Two most popular. One is called for-edit-mode. I don't use for-edit-mode. I mostly use smart parens. That's another choice. There's also one called parenfer, which I don't use. Maybe you find that one works better for you, but figure this out, because without it, it will be more difficult to navigate and work with Lisp. And once you, like, the beauty of this, you have figured these two things once, and they're pretty much the same, or at least similar for any other Lisps, because they all operate with the structure. So another thing is REPL-driven development. REPL-driven development is when you hear REPL, and if you have experience in Python, you think, oh, it's like kind of like Python REPL to a degree. The problem is that REPL stands for read eval print loop, and every stage here in read eval print loop in Lisp languages and non-Lispy languages, they differ. And sometimes there are small differences, sometimes they are pretty drastic. I will probably need to make another video explaining in detail why and how they differ. But basically, the essence of REPL-driven development, that you write expressions, like, for example, if I want to sum multiple numbers, I can just write them and eval that in place in my editor without like going anywhere. And this is very dynamic. Remember I told you about like that you need to you can't just look at the static Lisp like as a static entity. You typically grab it and start like playing with it. And what you want is to figure out like eval commands. There's eval buffer, define region. So for region, if I want to select some region and eval it, it will be evaluated automatically. So you basically, in Lisp, you live inside the REPL loop. REPL is not like some disconnected entity that you have to type things in. You're connected to REPL. Sometimes REPL actually may live in somewhere in a different location. Like, for example, for work, we use Clojure, and we have our Clojure REPL running in Kubernetes cluster. We can connect to the cluster and change things on the fly when we test things. All right, so structural editing and REPL-driven development, these are two things, don't ignore them. And let's go through the package. So, like I said, some of these keys are required, some of them mandatory. For MELPA, this one will be absolutely required. SPDX stands for Software Package Data Exchange. I believe it's for automated compliance scanning. The package requires this will the package managers, there are multiple different package managers for Emacs, and they typically figure out the way how the dependencies relate to each other in a package through these headers. And if you are writing a package, so again, you probably will start in just in a file or a scratch buffer. You start experimenting, writing some symbolic expressions, play with them, and then once you're ready, you save it, and you say like, oh, now I want to publish. You need this header. You can just grab it from a different package, already published package. Or if you're using Doom, Doom has an interesting feature. Doom Emacs has an interesting feature. So let me show you. So if I go to any directory outside of my config, and I try to create a file that is just Emacs Lisp file, it automatically would recognize, it would think that maybe you're trying to create a package, and it will give you this template that you can fill up and say like, oh, this is my package, and I don't know, it's for the news or something, right? And you can put the package requires. The way how it works in Doom has something called modules. And module in Doom is basically, it's the collection of packages. And the module that does that thing is called file templates. So if we go there and you see the packages, the only package this module has, it's snippet. It also does the snippet stuff, but then that thing for the package template, the logic for this is somewhere here. And the template itself, if we find Emacs Lisp mode, this is the template I believe it uses. So there's a that is some nice feature of Doom. If you're using Doom, you can just enable the module. All right, let's go through the package. SHR. SHR stands for Simple HTML Render. What it basically does, it renders some stuff in renders HTML in Emacs. So initially, I built like this package to work in EVD in Emacs web browser, and SHR uses certain like facilities to render things that way. DOM package is, these are all built-in packages. They're built-in, you don't have to install them separately. They're built-in, you just require them and you can start using them. So DOM is a DOM manipulation. It basically parses HTML structure into the Lisp structure, right? Let-alist is an interesting package. Let-alist is basically gives you a way to do destructuring. And if you ever seen Clojure, let me show you a Clojure example. I'm going to just create an empty Clojure mode package, and I will have to be connected to a REPL. So let me start a Clojure REPL. So I don't need to see the REPL itself. So I'm gonna just bury the window. And now let's see if our REPL worked. And if I'm evaluating, you can see that it's working, but this is Clojure, this is not Emacs Lisp. So in Clojure, there is something called destructuring. So if I have, for example, if I have hash map that has certain values, right? X1, Y42, and Z blah, right? We have this map. And now, if I want to get from this map, let's actually create this map with the stat map axis, and we say x is 32 or something, and x2 is 33, right? Now we can do it like this. We can have comments for readability, but comments are optional, or we can. So Clojure doesn't care. It cares about the structure, and the structure is maintained by the parentheses and this brackets. So we have our map, and now if I want to get the value of x2 here, I can do something like this: keys, right? And I can say, if I say access, right? And I need to say from where are we getting it? We're getting it from my map. And if I say like this, it will give me the value of XS. But I can continue. I can like down here, I can do keys from XS. I'm gonna get like X2 key. It also works. But there's also syntax for nested destructuring, but I don't want to bore you with the details. You get the point, right? Like the destructuring enclosure is really nice, and it also works for vectors or arrays, but they're not arrays. It's they called vectors, but for specific reasons. But so the destructuring works, and a list in eLisp, it destructures from a list association list. So if you have like certain keys and you want to grab them, it binds them to in a nice way. You can grab them. Outline is just like a bunch of functions to work with. Outline, organ indent, and self-explanatory. All right. Request we needed to. For HTTP calls, I don't know, I don't need this comment here. Well, why do I have require nil? So let's see, the feature, like when you require, in Emacs they called features, right? Like when you require something, it gets added to the features list. So if I see if I'm gonna run the command, you can run the describe command. There are a bunch of, you can see there are a bunch of describe commands in Emacs: describe phase, describe key, char, mode, and if you describe symbol, right, and you can type require, it will give you a description of that thing. But I use a different package called helpful, different thing. Describe is a built-in, helpful is a third-party package that needs to be installed separately, but it's a nicer way to see things. So if I want to see a symbol, right, and again on require, that's this is and because the difference from the built-in describe commands, that it gives you certain adds certain things that are just nicer here. So says if feature is okay, I was showing the helpful symbol of features, right? If we look at the list of features, you can see these are all the features or packages downloaded into my Emacs config, and there are tons of them, right? We can probably let's see if we can count them in our let's see, length is the function, I believe, and if I do features like this, let's see, I have over 1,000 packages loaded into my Emacs config. Imagine a VS Code user who just imports even a half of this number of extensions. So that's why we don't call them plugins or extensions, because they can live in the same space and interact with each other. All right. So now we were looking into the description of feature. So it takes the feature, the file name, and no error. The feature is not already loaded. I don't think I need this. I just I can leave it like this. All right. So now dev group. Why do we need the groups? The groups in packages, the group keyword is needed because when there are two ways of creating variables in Emacs. There's def var and there's def custom. All right. So def var, you just create kind of private. They're not encapsulated private in the sense that you cannot access them. Emacs gives you absolute freedom to access anything you want, but just semantically they kind of separate them, and I'll show you in what way. Def custom is basically customizable, user customizable variables, right? So when you have a group, and you can see that I have a group, and on each def custom I say this is my group, right? And when I say that, if I want to customize and I say customize group, and I say like, I want to customize wiktionary-bro group, and it will give me the values for, some people use this interface. I never use it, to be honest, because like in the beginning I used it. It kind of cool. You can change the values and then show the attributes, and this is we'll talk about the faces, but these are the variables, right? You can change the, let's see, the state standard, add comment, show option. So yeah, there's an interface to change the values of so yeah, if I want to change the built-in audio player, the pronunciation gets played through FFmpeg. FFmpeg is typically gets bundled with FFmpeg, so there's no good reason of not having FFmpeg on your machine, so that's why I use FFmpeg. But if, for example, you want to use aplay or something else, you can do it. And once I do this and I say like, apply this change, it will get applied. But again, I typically don't use this interface because it's honestly just setting variable in Emacs, right? This way is much more convenient to me as a Lisper. So we have the group, and in your package you want to have a group, and with a specific prefix, and then for your dev custom, the user customizable variables, you want to have this group keyword attached, right? So faces, what are the faces? Faces, everything that you see in Emacs, it's called face. They don't call them fonts because font is a part of the face, because face also has like, and we can again use describe face command, and if we use it like this, and it says like, whenever you see something wrong in Emacs, or like, different, like you want to say like, oh, I don't like the color of this, how do I change it? So you would write you would run a describe face, and you can see this is showing the face for this specific thing, and like most of these parameters are unspecified. Let's look into some different face. So for example, the face of this doc string, right? If I say describe face, it says like font lock doc face. This is the face I'm looking at, my cursor at the point. And if I enable rainbow mode, we can even see the color of that face, and there are some attributes, and we can change them on the fly. So let's try that. Set I think it's set face attribute. Oh yeah, like it gives me some example here right away. So we would say, oh, already forgot what was the face name, font lock face. So we need to quote it here, and then the difference between quoting and non-quoting, this way it points to the symbol. This one, it points to the variable. This way it points to the symbol that's bound to that variable. So set face attribute, if we look at the documentation, and in the DWIM, it's typically, just like in Vim, it's bound to control Shift K. So if I press Shift K, it looks up the documentation for the thing at point. So it says like it takes a face symbol, then frame, and if we give a nil, it means the current frame. And frame in Emacs is what you see, this window, right? And windows in Emacs, these panes are called the windows. And Emacs can have multiple frames, and if I make a frame, you can see it will exist as a separate like application window. Like, but let's delete this frame because we don't need it. And so don't get confused. The windows are these things that you see that we typically call them panes, and frames are application windows. now, so the frame is current frame, and let's change the foreground color to, let's first, I just want to make sure that I save this, because after I changed that, I lost my buffer. Where was it? Okay. So let's change that to red. See what happens. Okay. At the end of it, you would press Control X, Control E. Control X, Control E is eval. What is it bound to? Control X, Control E. It's eval last expression. In my machine, it's actually running a different thing. ERO is eval last expression. That is the function defined in this package, evaluation result overlays for Emacs. That's how you see it. It's evaluating right here. So we evaluate it, and you see that it immediately changed the color of that face. But I don't want that. Let's get back to this color. Right. So faces, we have multiple faces. I don't think they're used. I was experimenting. Oh, one of them. I was experimenting. I probably need to clean this up. I was experimenting. I wanted to have in the tables to make this more readable. Maybe I'll get back to it and figure this out. All right. Now we have functions. Functions in Emacs can be interactive and non-interactive. I will talk about the difference. Okay, so the function has the name, the parameters, and it needs to have a doc string. And if this one, you can see that it's wrapped like this. So if I don't do that, doc strings, when you publish, well, we'll probably get to that point. Whenever we talk about publishing the package, I will get to that point, and we'll hopefully I won't forget. So now, interactive, like I said, functions can be non-interactive, the ones that you call programmatically from Emacs Lisp, and there are interactive functions. They also called commands. And the commands, if you put this interactive header in the function, it will appear an MX menu, MetaX menu. So this particular command is here. All right. And if you look at the documentation of that, it's they're like, you can have like different letters. It's very extensive. You can do like lots of things with this interactive. Because interactive functions could be like of different different levels. So S specifically means code letters. Define S means read from mini buffer, number mini buffer. I believe S. Any string does not. So yeah, it basically reads a string from mini buffer. Okay, so if I run this command, pro play audio, you can see it says like on what URL. Technically, I don't have to have it like this. It doesn't have to be interactive, because this is getting called programmatically down here. You see that it's getting called whenever we push the button, but that's being called programmatically. So technically speaking, I don't need this to be interactive, so we can probably remove this. And then it's basically figures out the URL, and then says like I'm playing audio on this like URL, and starts the command. And remember our customized variable that by default plays on ffplay. Now, def-var local. There are two types of variables. There are global variables. When you say def custom or def-var, this variable will exist on the global level. It will be accessible within the session, your Emacs session, from all frames, from all windows, from every buffer. This will be a global variable. The local variables are buffer local, so they are set for the buffer. So for example, if I just say describe this symbol, wiktionary-bro current language, it would say its value is nil. I don't I mean, like, there's no value in this buffer. But if we open, oh, I actually can just run it here, right? Wiktionary-bro DWIM, and I say, what, open for Emacs, and I say, what is the symbol of current language? And it says, like, the value in this buffer is en for English, right? So these are local buffer local variables. All right, so now you can see this def-var. This is non-customizable variable, and this is a key map for the mode of Wiktionary-bro mode. So whenever, let me open that buffer, do I still have it? So you can see that this is running in major mode. In Emacs, every buffer has major modes, and one single major mode, and multiple, typically multiple minor modes. And we are creating major mode that is derived from org mode. So this is basically org mode with some sprinkled with like some additional things on top of it. And every mode has its own key map. And if you name it as such, it basically, if you have a key map, it just picks up. All right. So now we are saying like, okay, we have a key map. And we have this specific keys that bind to this specific commands, and this is a key map for this specific major mode. Now let's talk about lets in Emacs, and you will see like I have like let, and I have let asterisk somewhere. I promise I should have let asterisk. Well, I guess, oh yeah, here it is. So let and let asterisk. This is kind of a pretty so let's differ on I need to show you. So there's let, and in let, when you assign variables, they come in pairs. So x is 1, right? And now the second pair of the variable, it could be y is 2, right? And if I say x, return x from this block, and if I eval this, it will return 1. This makes sense. The difference between let and let star, that let does the binding in parallel, which means that all the bindings there are bound simultaneously, right? And that means that they cannot reference each other, meaning that if I want to do something add 2 to x, this is not going to work. It will say like, hey, listen, I don't know what you're talking about. I don't know what x is here, because it's trying to do in parallel, right? And if you want to do this, you would have to use let star. So this works because let binds them in sequence, and another big difference that all initial values are evaluated in the outer scope before any binding happens. Let me explain what I mean. So if I have something like this, right, and I do let here, and I will say like this will work now because we have x outside, right? And if I do this, what do you think the result would be? Right? It rebinds x, but what is result of y? It will be 102. Now, look how the difference here it makes. You see? So, and then you may ask, what the point of let at all? Why don't just use always this? Well, why do they even have let? So in formal logic and math, you typically define a set of variables all at once, not sequentially. So that mirrors that pattern, and it's kind of like faster, but it, like, you know, with the modern computing, you don't typically think like, you know, about binding variables in a more efficient manner. So there's an important distinction between let and let. Let's talk about make sparse schema. So make sparse schema. There are two different types of keymaps. There's make keymap and make sparse keymap. And the difference is that in sparse keymap, representation of keys, bindings are stored as association lists, okay, and rather than dense vector. The term sparse refers to the fact that you're only storing bindings for keys that you actually use, and this one, make keymap, it pre-allocates the space for all possible keys, and it's less memory efficient, but it's more it's faster to access the keys, right? Full keymaps are faster for looking up the keys because they have direct array indexing, but they kind of waste memory if you only bind just a few keys. So the general rule, if you want to bind more than 15, 20 keys, then you would want to use make keymap. And most like bigger major modes, they use this. And if you just binding, in this case, we're not gonna bind like too many keys here, so we use sparse keymap. Okay, we talked about keymaps. We talked about the mode. The mode is we use the mode that derives from org mode. The hooks, there is the mechanism in Emacs to so whenever you open file, for example, it runs a certain hook functions, right? And I needed to use this hook for a specific reason. So if we go to our Wiktionary buffer, and then if I want to come and jump to another Wiktionary entry like computing, right? So it basically, if I press Control HK is typically bound to describe key. And if you want to figure out what command binds to a key, you press that, and I'm trying to figure out like what is bound to return key. I press return and it says like, oh, it is bound to this function in this specific mode, in this specific key map, right? And then if I look into the implementation of this function, somewhere down there, I would find a link. It checks like what is the type of thing, right, you're running, and it checks the link and does the. So if I remove this hook, let's remove this hook for a second, right? So I remove hook. It's called for 4 arguments. Yes, I don't want to call it with 4 arguments. I just do this, so we no longer have the hook. And if I press this, oh, it still works. Oh, because I did not remove it. I know why. Because so let's see. Add hook. If you look at the documentation, it says like the hook itself, the function it binds to, the depth. The depth is like, think of it, the priority of the thing, and if it's local or not. So in this case, it says T, meaning that this hook is bound to this specific buffer. It doesn't. So this is made specifically so it doesn't change the behavior in other org mode buffers, which of course, I don't want. So if we want to remove the hook, I would have to evaluate this in the context of this buffer, and it will remove that hook specifically just for this buffer. So let me run this. I'm gonna press the key that does eval expression, so I can run it from here. Eval expression, meta colon, right? And then I can paste it here, run it, and now if I press computing, it's still taking the org. Hold on. Did I remove the hook? Org open at point functions. Yeah, it's still there, so it did not remove the hook. Org open dictionary handle. This should remove it. Why it's not removing it? It's still there. Oh, wait. What does remove hook takes? Remove hook takes. hook, function, and local. Of course, we forgot about the third parameter, so we'll do this. And now, if I press that, you see that it's going back to its default behavior, opening it in EWW. And so that's why I needed this hook, so I would run my own function that is handling the link. So in this function, it basically says like, hey, if you're in this major mode, which you don't have to check because it's typically would be in the local buffer mode, but I still it's a good practice to check in what mode I am, and then I will grab the thing at point that would be the link, and I will extract the information from the link, and then I would say like, hey, let's go and go to Wiktionary, open the Wiktionary entry. All right, so that's that. We're setting local buffer local variable for browsing function. So if by default it's actually uses default browser, so if we don't set that, that's the thing I mentioned. And the README, if you want the external links to open in your default browser, you can override this like this by just setting the hook, right? And now we have certain utility functions. This P is a convention in Emacs Lisp for predicates. Interestingly, in other Lisps like Common Lisp and Clojure, they use for predicates, I mean, like you can see that it stands like P for predicate, but in Clojure they use a question mark. So your like similar function like this would be in Clojure would be like defin. Am I in Clojure mode? No, where's my Clojure mode buffer? Here. So in Clojure mode, it will look like this. It will look like this, right? And that is interesting, right? Like you can immediately see, okay, am I at the beginning of the word? Question mark, right? Like, you don't have to, in JavaScript and Java, you would like say is blah, blah, but here it's just like different, right? So in Lisp, a symbol is essentially any sequence of characters that doesn't contain white space or special parsing delimiters like parentheses, brackets, or quotes. So that means that most punctuation characters are allowed in symbol names. So you can have, it's not unusual to see the names like, data plus some other crap, right? That's the name of the function, that's legit. Or you could be like this, or you often also see some functions in Clojure and other Lisps, like if you have date time and you're converting it to string, right? Like it could be like this. This is also a legit name for the function, which is pretty cool, right? So yes, and this is a convention for private, like they're not private. They're not encapsulated. You can absolutely access them, but this is a convention for kind of internal implementation functions. And if like the external API, the public API just uses single dashes, but for internal functions, you typically use the prefix of the package, then followed by 2 dashes and the rest of the function. All right. So we have a docstring, save-excursion. Save-excursion, a thing to save the cursor. So this is manipulating some, like doing like, if I run this thing, right, you see like forward word, you see that it's actually going back and forward, right? But if I evaluate this whole thing, it's it's not, it doesn't know the word and point. So like let me show you. So if I put backward word and evaluate it, you can see that it's like working. It just immediately taking this can in effect. But if I say save excursion and evaluate the same thing again, it does nothing. It stays where it is. But basically, this function says do something, go backward, go forward, and figure out like compare the difference, but do not move the cursor. Put like cursor back where it was after you do that, right? There's save excursion, and there's also save mark and excursion. Save mark and excursion. This is if you have a selection, it also won't be affected. So this is a pretty common pattern in Emacs Lisp. All right, yeah, we have some other utility functions. We have something, this is the main functions becoming that render things. These are the functions that render the layout of tables. This one probably like pretty big, right? What else can I cover? Let's see. I think, oh, this one's interesting. So this function is pretty cool. This is not a function. This is actually a macro, and it basically says temporarily bind to places. This is a very powerful technique, and I suggest you if I Google cl-letf and let's see cl-letf. If I just Google that thing, I'm pretty sure I will find something. Okay, so this page, put a bookmark on it because it explains there are three different functions: cl-let, labels, and cl-letf. So they all work differently, and they are very powerful because they allow you to basically overwrite things in like on the fly, which is total bananas. Let me get rid of the come on, what's happening? Get rid of the browser here. Okay, so what this is basically saying, for when you're rendering the DOM and you encounter like you need to call this function, just ignore it. Outright ignore it. I don't want any images because I don't care about images, right? And the reason I don't care about images on Wiktionary pages because the images usually like small, a few pixels of like different like buttons, and they don't like render properly in org mode anyway. So we remove edit buttons and so on. So you can see how powerful. So basically this is overriding a bunch of functions that's supposed to like, basically I'm taking the structure, echelon structure, and rendering it differently, overriding a bunch of functions that override them. That's supposed to render them, but like I want to do that differently. Right, regexes. Regexes is one of the things that very confusing for the beginners, because look at this. This is just, I mean, like this is a pretty simple regex, but it looks intimidating because historically ELSP uses so-called extended regex syntax, where special characters need backslashes. They need to be escaped in the regex itself. I honestly, why they don't add something like in Python? They have like something like this, right? And I think in Rust they have something like this. I think it's like this. Am I right? Yeah, something like this, right? In Rust, but Emacs doesn't have things like that. You have to escape, but there is a helper if you want to just figure some regex. There's a regex-quote function. So if you want to say this is my regex and I want to convert it to like Emacs regex with extended syntax, it will do it for you. Also, Emacs has a really nice thing called regex-builder when you're trying to figure out like regex. So this one you can start like I want to match on the parenthesis, and starts with setq. You can see this is matching interactively. You can build like your regexes. This is a very, very nice thing. So use it. All right. So regexes, and these are some more helper functions, handle links, change language function. Change language is also interactive. You can see it takes the list of the languages it works and a little bit different, like than the other interactive functions we had. Rendering part, the lookup part. This is where it sends the request, tries to hexify the parameters and all that. Then we have the main command and provide. So the provide part is basically that what registers a module and package and adds it to the feature list. So remember our features. So this, and it should be here, right? And so this provide actually adds this, and this part is also needs to be here. Okay, so that's pretty much the structure of the package. Now let's talk about what do you need to, like, let's say you wrote a package, it looks good, now you want to publish it. Okay, I'm gonna revert my changes here, whatever I did, the experiments. So you want to publish the package. Well, you need to, you go to MELPA. Okay, let's, let me bring to my browser. You go to MELPA on GitHub, and you clone this. Repository, and you basically create a pull request. Let me show you what you need to. Once you clone it, I have it cloned. Let's go find it. MELPA, it's in here. So MELPA has like the structure and has like recipes, and every recipe, let's find the recipe for our package wiktionary-bro. It's a single line that looks like this. It's the name of the package, where you're getting from, and the repository. That's it. That's all you need to do. All right, so you basically fork the MELPA and create a branch, and then create a pull request with, you can see that these are the pull requests for all packages that being reviewed right now, like people have been adding packages. So as wiktionary-bro recipe, this is my pull request. Again, the change is minimal. But then there is a process, there's a checklist. First of all, you would have to have GPL compatible license. You read through this thing. You will have to test it. You will have to, it's not too much to read through. And then you would have to run package-lint, and let's see if I ran it. Package-lint current buffer. So package request is not installable. This is the thing that is not. I think it's the. I'm not sure why it does this. It doesn't see that request is not installable. It's actually, this is not true. This is a red herring. It can be ignored. But there's other things you need to run. There's checkdoc. Checkdoc you need to run. So checkdoc checks that all the comments have like doc strings and they are properly formatted. So Emacs is famous for built-in documentation. All the functions need to have doc strings, and this enforces it. So for example, remember I was talking about wrapping some symbols in doc strings. I think it was somewhere up here. Oh, here. So if I remove this, right, and save that, and then run checkdoc, you see what it says. It says like, hey, this symbol should appear in quotes. So at this point, you can press E, and E is for edit, and just change it yourself. N is next, and P, but we only have one, so N is the next, and P is previous, but we only have one. And if I press F, it just automatically fixes it. Okay, so that's, oh wait, F, okay, so yeah, like it fixed it, and that's all. Then you publish, you create a PR and just wait for them to review it. And maintainers of MELPA, they're pretty responsive, they're pretty good. They do thorough reviews of the pull requests here. I sometimes go just out of interest to what people are trying to publish. You can see there are lots of, there's always lots of activity. There are over, oh wow, there are like, I don't know, like, I suppose most of these are published packages. Some of them they probably closed without allowing them to publish, but you can see that this is a big number. MELPA has a lot of packages, and you can search them, search for packages here. So for example, if you want something that deals with, I don't know, YAML, right, there are like a bunch of YAML packages, or Rust, or let's say Clojure. Oh, there's so many Clojure things. I had no idea. Anyway, I think this is all that I have for today, and sorry for such a long video. Hopefully that was educational.